is our project. It's a 3x3 LED grid to play Tic Tac Toe on. This is how we started. This is the final outcome. The first thing, we had to put all the LEDs, 81 LEDs, on a cardboard foam board piece. And okay, the first problem we met was through the Altera board we can only get 3.3 volts maximum from each output pin. So we had to avoid connecting any LEDs in series. So to do that, we had to connect them all in parallel, and that's where these copper wires come in. Every copper wire surrounds the first one surrounds all the positive edges for the LEDs that are going to light up the X, and another wire for the positive edges for the LEDs that are going to light up the O, and one wire common for all the negative edges. Each and every single one of these wires is soldered using a soldering iron and solder to hold them in place to be connected to the ground. We did that for all 9 boxes.
You see, this wire is connected to the positive O, which are all connected together, and then there is this wire here connected to the positive X. And take this one for example, this is connected to the negative, so we only needed 3 wires per slot in the 3x3 grid.
Now we have to connect them to our breadboard so we can access our Altera board through the pins. Each wire here corresponds to 2 pins on the GPIO pins for the Altera. For example, this wire could be an X or an O for the first slot. The second wire could be an X or an O for the second slot, and so on for each of the 9 slots. They're connected to the breadboard, which is connected to the wires on our original board. And when you get a signal from the Altera giving your code, either an X or an O are going to light up per slot, depending on how you code it. For our project, we coded every wire for these 18 wires, and 1 ground corresponds to every wire corresponds to either an X or an O. So we need 18 wires for 9 slots on the 3x3 grid.
We'll demonstrate now a live game.
Okay, each one of we are using 9 switches to correspond to 9 different positions. Each switch corresponds to a different position with a reset button. This, we played the first switch, and it was X's turn. This was the was the 4th switch and O's turn. This was the 2nd switch and X's turn, and this keeps alternating. This was the 3rd switch, it was O's turn, and there is a different switch to change the turns between X and O. Now this is the 7th switch, X's turn. And here we have the 6th switch and O's turn. Last one, O is going to play in the 9th switch, the 9th place, and O will win. When O wins, this happens. Everything